Hello, I'm Jacob Schmidt. This is a history and real-life applications of sequences and series, my presentation. So there are three different types of series. Obviously, we know that from class. Arithmetic, geometric, and harmonic. These are just the basic formulas. You're welcome to pause and read them. They're just from class. Um, Main two is arithmetic and geometric, and I just put harmonic on there because it has an interesting history. So the arithmetic series definition is a concept in mathematics. It's been studied. It involves the sum of sequence of numbers in which the difference between the consecutive terms remains constant. So you can see right here the difference between all these terms is all constant. I have the same image later on to show you the geometric to compare the two. But we'll talk about that later. But yep, so the differences is all constant. That's all that is. So the history of the arithmetic series has ancient origins dating back to the Egyptians and Babylonians. They had basic knowledge of arithmetic progressions. They developed an understanding of patterns and with constant differences, which is what I just talked about. So Euclid, he's a Greek mathematician. He wrote a book called Elements. We'll talk about that later, just a little bit. Discussed arithmetic progressions and properties and calculated the sum of the terms. Then we got Al-Khwarizmi. I'm not sure if that's how you pronounce it. This is him right here. And he was a Persian mathematician during the Islamic Golden Age, made significant contributions to the arithmetic series. He wrote a book called Algebra. We'll talk about that as well. And discussed arithmetic progressions, providing insight on properties and calculations. Then we got Al-Khwarizmi, this one right here. This is him over here. And he was a Persian mathematician and formal development of arithmetic series, studied properties, arithmetic progressions, and provided the formulas for the sum calculations. We got Blaise Pascal, if you know about the Pascal triangle. This is him right here. And he was a French mathematician, introduced arithmetic triangle. That's the Pascal's triangle. He called it the Trage du triangle arithmetique, French. Revealed properties of arithmetic series. And then, of course, on to modern times, just refined, and we started using the applications of arithmetic series to know more stuff, which moves on to real-life applications. So in physics, when an object undergoes acceleration, if you graph it, it's like the constant differences, right? What we just talked about. And you can model that using an arithmetic series. Computer science, algorithms can involve arithmetic series. Engineering, calculations involving evenly spaced data such as signal processing. And this is part of the engineering side of it right here. The synthetic EKG, you can see the difference between all these is constant. Moving on all the way through here, this just brings into other like variables into it, so you got noise and filter and all that, but this is what mainly I was wanting to use as an example, the constant differences between all of them. Moving on. So what's geometric series? Moving on to that. So like I said earlier, this is the same picture, but geometric series is a series of numbers in which each term is found by multiplying the previous term by a constant factor, common ratio r. This is a formula from class. And that's the common ratio r here, and you've got the actual definition. You can pause if you need to read that, but here you can see the difference between all of them are all exponential. So that's all that is showing exponential versus the constant differences here. So history geometric series, ancient contributions again, Babylon and ancient Egypt, Greece, talking about Euclid. This is that book I was talking about earlier, Elements in Euclid. He laid out the foundation for geometric series. Euclid's Element is a mathematical writing consisting of 13 books. Of course, Euclid wrote it. And then we got Al-Khwarizmi again from Persia, or he was Persian mathematician. And this is his book about the algebra. So, of course, I don't know if you can read that. That's all in different language because, of course, it's been translated. And he introduced discussions of arithmetic and geometric progressions. Earlier we were just talking about arithmetic, but he kind of did both. Renaissance and post-Renaissance era. So all these guys did it, helped contribute to all that. Basically, Stephenville was German, and then Napier was Scottish, and Stephen was Dutch, and expanded the understanding of geometric series, and used the series in applications in various fields. And so there's those two books I mentioned earlier, and now, of course. Real-life application geometric series. So you got compound interest calculations, interest on a loan, you got population growth. You got two people, right? And it webs out super fast, exponential growth. You got radioactive decay. That's what this is. Radioactive isotopes. So this is half-lives. I don't know if anyone who's watching this knows anything about chemistry, but the half-life of this is cobalt-60, and half-life goes down exponentially over time. So this one half-life is 5 years. So this is period over 5 years and percent of cobalt remaining. So you can see it goes down exponentially, and that's just a geometric series. And also, if you know about fractals, the self-repeating patterns found in nature and computer graphics, that's also a geometric series. So what's a harmonic series? Harmonic series is an infinite series consisting of positive and integers. So you can read that if you want to. Pause. General form is this right here. History of harmonic series. Ancient Greece again. Pythagoras, the same person as Pythagorean theorem. A squared plus b squared equals c squared. The same guy. This is him right here. And he was figuring it out with the length of a musical string, a harmonic series. We'll talk about that in the next slide. Zeno of Ile, he had help with it as well. And then Bernoulli's principle is not the same person as the other one. So not the same person who discovered Bernoulli. That was Daniel Bernoulli, involving air pressure and compression. Jacob Bernoulli was the one who was helping out with harmonic series. And yeah. So here I was talking about earlier with the musical string. So these are the notes. And then you've got the notes into the graphs, like the sound waves, and that's showing it graphically. But that's a harmonic series, and this is a harmonic series, graphically, mathematically, I guess you could say, and then in music. So here's some examples. Physics harmonic series is study of waves and oscillations. Electrical engineering, AC currents. You can read the full pause and read the full definition if you want to. And signal processing. And that is it. Here's my sources, and thank you for watching.